Then we can now solve this differential equation using the separable by integrating both sides. So we have dx all over x minus the integral of w dw all over 4 plus w squared is equal to 0. Okay, so this yields to the general solution of the integral of this part is ln of x, and the integral of this is since we have w squared here and we have w dw, the derivative of this is 2 w dw. So we have w dw here, so we need to divide it by 2. So we have 1/2 ln of this part 4 plus w squared, and then plus or equal to our c, since our technique, once again, if we have both ln, then let's use a ln of c here for easy computation. Or we can further simplify this by doing the rules in logarithm. So we have x, since we have a minus, so we have x all over maybe let's try to multiply both sides by 2, since we have 1/2 here. So if we do so, we have 2 ln of x minus ln 4 plus w squared is equal to 2 ln of c, and we have ln of x squared, so we move this 2 at the as the power of our x, so we have minus ln 4 plus w squared is equal to ln of c squared. Then combining this, so we have ln x squared all over 4 plus w squared is equal to ln of c squared, or just ln of c. And applying the exponential, so we get x squared all over 4 plus w squared is equal to c squared. And we're not done yet, because we need to bring back the value of our w, which is equal to y over x, right? Yung substitution natin, this part, need to bring this back in order for us to make our equation or solution in terms of x and y, or in terms of our original variables. Okay, so we have x squared all over 4 plus our equation here, we have y all over x squared is equal to c squared. So this is now our general solution. If you still want to simplify this, then we have to simplify this part. So we have x squared all over this will become y squared x squared, so we have 4 x squared plus y squared multiplying this. Okay, then we have c squared. Okay, so instead of this, we can also express our general solution in terms of this, and we can also express this in other form. Okay, but the main point here is that if we have a solution that is not separable, then we may try if we can use the homogeneous equation. So by doing that, we check if the given equation is homogeneous by substituting lambda. And after we've proved that this is homogeneous, we can now substitute the value of w, which is equal to y over x, and some modifications here, and then apply the substitution on our original dE to make this dE a separable one. Okay, so after making the solution into separable, then we may now find the solution by integrating both sides or by doing the steps in separable equation to come up with the general solution.